Welcome to Chapter 1, Section 7, Conditional Logic and Regular Expressions. By the end of this module, you will understand both if statements and regular expressions, and how they can be applied to cybersecurity tasks such as authentication, port scanning, and validating user input. In cybersecurity, we often need our code to make decisions. For example, did the user enter the right password? Is a port open or closed? Or should suspicious behavior trigger an alert? Python if statements allow us to build these kinds of decisions in our scripts. Let's take a look at an example. I'm going to jump into some code here, create a new file here, and we'll just call this authentication.py. All right, the first thing we want to do is create a generic password. Now this password is in plain text, and you would never want to store a password at rest in plain text. That's obviously a security risk. The next thing we want to do is prompt the user for a password. So we'll use the input. So input allows us to pass a parameter as an argument, which is a string that will be the prompt. So let's put enter password. Then we can use the if selection or the if statement to make a selection to determine if the user entered the correct password or not. So the first thing we do is start with the keyword if, and then we need a Boolean expression to evaluate. In this case, we're going to check if password is equal to, and notice when we use comparison of strings, we use two equal signs. A single equal sign is the assignment operator that assigns what's on the right side of the equal sign into the variable on the left side. So we'll check if password is equal to entered password, and if that is returns true, meaning they are equal, then we'll print out access granted. Otherwise, we'll print access denied. Now this is a dual alternative selection statement, meaning we have two paths of execution. So if the passwords are equal, we have this path of execution, and if they are not equal, we go through this path of execution. That's a dual alternative. If I get rid of this else, this is a single alternative selection statement where we only have one alternate path. Let's go ahead and save this, and then we'll just run this. So Python 3 authentication, and we'll enter just a password. I'm going to put password in, and you can see access is denied. Now if I put the correct password in, you can see access is granted. Another use case would be to simulate a port scanner. Using if, elif, and else, we can detect which service is likely running based on a port number. In this example, we're checking the port. If it's equal to 22, then we print out SSH service. If the port is equal to 80, we'll print out HTTP service. If the port is equal to 443, then we'll print HTTPS service. Otherwise, we'll print out unknown port. Now this will have value as we progress through the course and work on Savage Scan, which is basically a network scanning utility for offensive security professionals. We can also nest if statements. So in this case, we're checking both the role and multi-factor. So if the role is admin and if multi-factor, then we're printing admin access granted with MFA. Otherwise, we're just printing MFA required. If the role is not admin, then there's another alternative in the else statement where we just print standard user access granted. Let's jump into Python and take a look at how we can do this. Let's create another file and we'll just do role.py. So we have the user role, and let's make this a little bit more interactive. So user role equals input, and we'll just grab the user role from the user and MFA. Let's make this a little bit more realistic. So if user role equals admin, then we're going to prompt the user for a MFA token. And let's say valid token. Let's set a variable here. Then we'll check if the MFA token or the MFA that's entered is equal to the valid token. Then we'll print access granted. Otherwise, we'll print invalid MFA token. If it's not an admin, then we'll just print standard access granted. Just like that. We can save this and we'll go ahead and run roles.py. Now if I enter admin, I'm prompted for a token, and if I enter the right token, 1 2 3 4 5 6, let me see, this is a string when it's returned here, so we want to cast it to an int. So int or instead of casting, we'll just make our token a string by wrapping it in double quotes. So we'll enter admin 1 2 3 4 5 6, and you can see access is granted. Now if we enter another role, anything but admin, we just get standard access. And if we enter admin and the wrong token, we get invalid MFA token. So you can see how we can use nested if statements to create multiple paths of execution. So far, we've seen how if statements let us enforce decision making, but what if we need to validate structured input like IP addresses? That's where regular expressions come in. Regex gives us patterns to validate text. We use the \d to match digits. The quotation mark makes something optional, and square brackets define a set of valid characters. We can combine these to match numbers and formats like IPs. If we look at an IP address, IP version 4 address, we have 4 octets separated by dots. Each octet is 0 to 255, for example 192.168.0.1. We can create a real basic IPv4 regex to match IP addresses. Now this regex is oversimplified and will allow invalid IP addresses, but many times is used to grab IP addresses from log entries, for example. So let's go ahead and jump in to some code and learn how to use the RE module to build a regex for testing for IP addresses. Now, the challenge will be to make a better regular expression to validate IP addresses at the end of this lecture. So let's go ahead and create a file called validate IP. We'll do a simple prompt, so IP equals input, enter IP. And I'm going to go ahead and import the RE module. RE is built into the standard Python library and allows us to use regular expression patterns to match for matching. So the next thing we want to do is grab our regular expression here. So the caret represents anchor to the front, and the $sign means anchor to the end. So let's go ahead and start building this. We'll say our regex equals, and we're going to use R for a regular expression. We'll anchor to the first digit, and then we want 3 digits. So when we use the curly braces, it will repeat the predecessor, this /d, the number of times we put in our parentheses. So up to 3 digits. So 1 to 3, 1 comma 3, we could have 1 digit up to 3 digits, followed by a period, followed by another 1 to 3 digits, followed by a period. Now we're using the / in this case to escape the period, because the period is a special character in regular expressions that means any character, match any character. But we want to treat it as the literal period, so we're using / to escape it. So same thing here, 1 to 3 digits, followed by another period, followed by 1 to 3 digits. then we'll use the $sign to anchor at the end of the string. That's our regular expression. So what we can do then is try to match the IP versus the regular expression. So the user inputted. So what we'll do is if regular expression, so regex dot match, and we'll pass in our regex. We need to compile this, so dot compile. Let's make a variable called R. We'll do regex re.compile, and we'll pass in our regex. So what this does is compiles the expression, the pattern, into a regular expression object that we can use to call match. So we'll say r.match, and then we'll pass in the IP address here. So if that matches, if it matches, it'll return true. If it doesn't match, it'll return false. So we can do print valid IP, else we can print invalid IP. Let's go ahead and save this and see if we coded this correctly. I'll jump into my terminal and we'll run validate IP. We'll enter a valid one and we get valid IP. Now let's enter an invalid one and we get invalid IP. Now there is a problem with this regular expression, and we need to improve upon this for Savage Scan, and that is it will allow 3 digits, so we could go outside the range of IP addresses. So let's run this again and I'll show you what I mean. We could actually put 999.999.999.999, and that is valid IP according to our program, but this is really not a valid IP. The highest IP we could have is 255.255.255.255. So this is not a great regular expression. In our challenge or trial, I try it code, we will actually improve Savage Scan and we'll make a better regular expression to validate IP addresses. All right, there are some coding challenges for you. If you jump into the walkthrough material, you can see that for chapter 1.7, there's a coding challenge to validate a MAC address. So take a look at that challenge. And then before we jump into the PyFiglet module, we'll actually apply the concepts that we learned in this module to our Savage Scan utility and have our Savage Scan utility validate IP addresses. And we'll create a better regular expression that will actually validate IP addresses.